Okay, so again, welcome everybody to this monthly meeting of the Doñana County Historical Society. Before I introduce our speaker tonight, I just want to tell you that next month we will have another meeting, and the presenter at that meeting will be Dr. Timothy Nelson. He will be presenting on Blackdom and the Afro frontier in New Mexico. If you haven't seen his presentation before, it's really, really great. So I encourage you to be here for that one, third Thursday of the month in May. So we hope to see you there. We are really happy tonight to have with us Dr. Dave Dubois. Dr. Dubois is the state climatologist for New Mexico, and he's also the director of the New Mexico Climate Center and an associate professor at New Mexico State University. He provides climate and climate change information to policymakers, the agricultural community, industry, educators, students, and the public throughout the state. He also gives numerous talks and holds workshops every year on topics covering climate, drought, air quality, and climate change. He teaches and trains students at New Mexico State University and maintains an active research program in air quality and climate. And as if that's not enough, he also chairs the New Mexico Drought Monitoring Work Group. So thank you for being with us tonight, Dr. Dubois, and I will turn it over to you.
All right. Let me get this. All right. So everybody can hear and see the first slide, right?
Yes.
All right. So we're good then. Okay. Well, thanks for that introduction. And first of all, congratulations on the award. That's wonderful. I really appreciate the work that you guys do to learn about our history. And then we're going to look about a little bit about that in terms of weather and climate. So we're going to talk about climate, and then the second part of it is we're going to talk about how you can take part in that and help us collect climate information as a citizen scientist. So everybody can take part. So that I'll give you some tips and opportunities that you can do in your house. So I start off looking back before we have instruments. So I enjoy reading articles that look at going back several hundred years, more than 500 years, to look at tree ring records. And so how can we glean information about droughts? And so this was one paper was published last year to kind of put together what were some of the worst droughts that we've had in North America. And this was some of the graphics on the right show some of the brown colors in the negative, in that both the SPI and the PDSI, those are drought indicators. If it's negative, strong, the more negative it is, the drier it is. And then the more positive, the higher positive numbers are wetter. So as you can see over on the left, upper left side, that map in there, then as map A, it's sort of winter and early in winter and spring. That particular time, 1568 to 1591, of one of the most intense droughts we've seen in North America. And so we have seen droughts here, very extreme. And so how do some of our current droughts map and compare to some of those really, really dry ones? So a little more recent, and this is again another source of data that was from tree rings. So these are the dendrochronologists who use tree rings, and then they calibrate the current weather data with the tree rings, and then they can go back in time. So this was my colleague Connie Woodhouse at University of Arizona published this a few years ago, looking at the past 349 years. And these are particular, see on the bottom right, there's a map of New Mexico, and there's a box with some triangles on it. And those are the focus area. So these are in southern New Mexico to look at the summer precipitation. So the map, the chart in the middle is is a reconstructed summertime. So June and July, those 2 months over the last 349 years. And then it's actually a smooth line. So 10-year moving average. As you can see, I've noted down some of the wet times where the green arrows on the top, and then on the bottom of the chart, there's some orange arrows, and those are the driest. And then I made a little chart on the bottom left that kind of puts in perspective when those occurred. So you can see some of those, like the droughts of early on. So like the 1664, let me turn on the little highlighter deal, and zoom helps out, laser pointer. So this little guy here was a very extreme, intense drought, but it wasn't as long as some of the other droughts. So even like the recent one, the 50s drought. And so that wasn't as dry, but it spanned over many years. And so, we've seen really dry times in the 1700s, and again in the 1800s, late 1800s in this area. And so that's kind of our record. And it's fascinating to see other historical documents that were during those times, and how has the lack of precipitation impacted society. That's the really fun part. And I won't have a lot of information on that, but I'm mainly providing on the environment, what was. And then other side of that are these really wet years, when we have really prolonged wet years above the long-term average of in that 2-month period, our average is about 2 inches, and sometimes they're more than a quarter of inch more than that. So interesting look at the past. And so this goes back 349 years, but let's look at the instrumental record when we actually have thermometers and rain gauges. So this is a map. I've got some of these in my office, and I pulled one from 1897 to show what kind of weather observations we had back in before 1900. And this was a particularly interesting one because I like to look at the shapes of the counties back then. And so some of them were very different areas than they are currently. And that's kind of a lot of historical context there. So a lot of our data comes from the Civil War. So they were first started in the Civil War, and some of them continued on after the Civil War, and some of them stopped. So there were a few, and I'll show you the next slide here is a climatological annual summary for the year 1897. And basically it goes by station, and then it tells you what county, and then, then it shows some of the climatological data. But it's very interesting to see where they were taking data and how long they've been actually collecting data as of 1897. So if you can, on the bottom here, which I sort of cut off some of the other ones, but sort of like Fort Bayard, Fort Union, Fort Wingate, they were collecting data for more than 20 years, sometimes more than 30 years, as of 1897. So they've had a nice period of record, and no longer taking data at any of these, unfortunately. Fort Bayard, I think, stopped in 2013, I think. And it's one of my projects before I retire is to get that back and running again. It's somewhere near there to continue that. But anyway, it's sort of interesting. In Albuquerque, they had 21 years already as of 1897. So there are some information around the state that we can glean some information of the past. So since we're in Las Cruces, let's look at, I want to give you a little bit of, before we go to Las Cruces, I want to give you a little bit of a historical context of how we did monitoring across the country. And I've been doing a little bit of research myself. And so there's been some nice summary papers written about this. And I actually visited the place in Wilmington, Delaware, where they had the first systematic weather observations. And back in 1644 to 1645, there's it's a fort on the in Wilmington. They actually have some reconstructed. They actually have a old boat, a sailboat that actually they go up and down the river. But that's about when we started collecting data, is in the 1600s. However, not a lot of continuous, in the 16 and 1700s. People like Thomas Jefferson collected data through 1816. And then not until the early 1800s, through the U.S. Surgeon General, we started to think about a national network. And then more likely in the mid 1800s, we were getting, because of the increase in the traveling, with horseback and then later on in the railroad, we had weather reports, and then with the lines being more, you can get information back very quickly. In the late 1800s is more when things start to really ramp up. And so 1897 is when Congress funded a national network, and that's kind of and it went into civilian hands. It went kind of the War Department, and went into a more of a civilian part of the government, the U.S. Weather Bureau, in 1891. So that's kind of when things really started to get going. And then the observations started to come in right in 1892 to 1895. And then fast forward all the way to the 60s, we had the National Weather Service. It started in 1965. And then we've got the map over on the right shows you all the different offices that are in the country. There's 122 forecast offices that exist today, but they've all had a history, starting out with, like we said, with these networks, but starting in the mid 1800s, and then more recently in the 60s and 70s, and now we've got more funding and more sites. So going to Las Cruces, so we have our main set of data that is available is 1895 to the present, although we started to collect data right around 1892, as much as I've been able to see. And so some of the a few of the statistics for here in Las Cruces at the NMSU campus, it was before it was called New Mexico State. We actually had a station here, and here's some of the stats. So the coldest it's ever gotten here in Las Cruces was 10 below zero in 1962. The hottest was in 1994, 110 degrees Fahrenheit. And the most rain we got in one day was 6.49 inches. And I'm actually going to be talking a little more about that. Back in August of 1935. Snowiest year was 1931. We had 14 inches of snow that year. It's amazing. And that bar graph on the right shows you the monthly average precipitation. So as you can see, we're this time of year in March and April is driest time of the year. And then we're a monsoon driven in terms of annual precipitation. So July, August, September are most rainfall throughout the year. And then again, it dies down in November and starts to uptick again a little bit in December. So that's our cycle of precipitation here in Las Cruces. The further you get west, the stronger this monsoon cycle gets. Further east you go, the more precipitation comes in March and April and May. As you get into Texas, those are some of the wetter months into the spring, whereas here we're in the drier months. So it all depends on where the source of moisture comes from, what body of water, and the air patterns, highs and lows. So we're right in the middle we're the dividing line between the Intermountain West and the wet in the east and dry in the west. So we get most of our precip. 45 to 50% of our precip comes from the monsoon period in the summer. So where do we collect our data here in Las Cruces? So this is actually the picture of our observation site here on the NMSU campus. On the left is actually that's how we collect it. It's all manual. So we make copies of this little piece of paper, and we write the highs and lows. There's a little button here that gives you the max and min, and then it gives you a readout. And we write those down manually with this pencil. We write all that down. We actually we collect rainfall, and we do soil temperatures. We actually do we have an evaporation pan that measures evaporation as well as the temperatures and rainfall, and then we enter that in every day. And so these are the sensors. This is our temperature measurement. It's called the maximum temperature sensor. It's basically just all we record every day is the high, which is usually yesterday. and then the low, which is this morning's. It doesn't always happen that way, when storms come in, but that's our data. And then this little white thing in the back, which I'll show a little bit here, zoom in. That's our recording rain gauge, measures precip over every 15 minutes. So there's a little electronic sensor, and it weighs how much precipitation. There's a hole on top, and there's like a little 5-gallon bucket in there that collects the precip. Right now, it's all zeros because it's dry. And then we have another rain gauge, which is called the standard 8-inch rain gauge. So that's, we measure rain or precipitation, snowfall as well. And this is the standard gauge that's used all over the world. And very simple. It's just a cylinder with that measures how high the water is inside. So very, very simple, but it's the standard meteorological observation throughout the whole world, and everybody does it about the same time in the morning. So that's our basis for climate, and this is on the NMSU campus. So back there, all those cars are, that's university, university, and some of the fields in the way in the background. So it relies on people. So we've got a rich history since we've been measuring data back in the late 1800s. A lot of observers. I may have missed a few, but I've been writing down names of the folks who've been signing the reports every month. Susie's been our observer on campus since 2001. As you can see, the names all the way down to Fabian Garcia. He was one of our first observers, and I've got some of his original signed monthly weather records from 1896. And I don't have a lot of photos of a lot of these folks, but this is one of the photos I got of Overpeck and getting an award back in 1961. And I think he was one of the faculty back, I think starting in 1927 or so. And he was sort of one of the directors back then, he also was one of the observers who took the data as well as being the director. So he was this is a prestigious award, the Campanius Holm Award, which is only a few people get it per year for their detailed work in getting climate data in the National Weather Service network. So it's all people doing this. These are all the long-term observations are all manually done. Somebody goes out and reads the observations every day and meticulously quality assures and quality checks them, and it goes into a national database, and all over the country. This is what we do. We do have other automated sensors. I won't talk a lot about that, but we do have those, and so we come up with statistics like this. So have there been trends in temperatures over time? And so we've seen lots of warming across the New Mexico and across the world, actually. So this is the summertime temperature trend since 1970. And so each of the little boundaries are the climate divisions. We've got 8 of those. And those are areas of New Mexico that have similar climate. And so those numbers are the trend per decade. So in the southern desert of New Mexico, the trend over this entire southern desert areas is 6 degrees Fahrenheit per decade. And so and some of them are more or less over on the southeast, it's trending 0.8 degrees Fahrenheit per decade. And so what is it going on in Las Cruces? So we're seeing an increase in temperatures, and this is a plot I generated that is the number of days between freezes in the last 128 years. So there's a lot of scatter throughout, but then right around in the 70s, we saw this trend. So that's what I was showing. So this is the days between freezing. So normally we have our number of days between freezing right around 200. And then, but although we're up to somewhere around 260 or so, so we're adding about 60 more days. We call it sort of like a growing season. So this is freezing 32 degrees. So, and this is similar to what we're seeing all over the place. I gave a talk in Albuquerque, virtually, of course, and we're seeing a similar type of trend in other areas. And then looking in the Gila, as well as in the northern, as well as other places where I used to work in Nevada, very similar trend. we're seeing across the country. So looking at Doña Ana County, average annual temperatures since we started collecting data back in 1895. So all the little dots in this graph are annual temperatures. So you can see a lot of variability. The black line is that long-term mean, the 1901 to 2000 average. And here's our trend going up. And then so 2017 was our warmest. It was a whopping 4.2 degrees above this average. And we've seen this, and the last dot is the 2020. So it was tied for third warmest. And so in Las Cruces, our trend since 1970 has been 0.8 degrees Fahrenheit per decade since 1970. And so only thing I'm going to mention about what do we potentially look in the future. This is one of the graphs I use for looking at climate change. And so this is one of we call them climate scenarios. And this is more of the more warmer ones. And so it's likely not going to be as warm as this scenario, but this sort of I wouldn't say worst case, but it's one of our warmer ones. And so right now our average annual temperature historically is about 62.6 degrees. And if we use the climate models over time toward the middle of the century up until 2069 or so, we're around 67, so about 5 degrees warmer. And then if we go all the way till the end of the century, we're in territory over 70 degrees, 71. And so what does that mean? So at the end of the century, which is a long time from now, our annual temperature will be similar to Chandler, Arizona. It'd be basically the Phoenix area for this high emission scenario. So take it or leave it. If you say this is going to happen, but it's sort of that trend of warming. And if things go this bad, things will look like this. And so El Paso has an average annual temperature of 64.6, which is basically our temperatures of the 2010 to 39. So these are some of the guiding, thinking about what our future climate could look like. And so, putting things in context of, what does it look like in the past compared to the future? That's kind of what I do in terms of scenarios. So what kind of things are risk and scenarios where they're warmer, may have the same precip, but what are the implications? So that's kind of what I do in terms of, water. And so like I said, there's not a lot of temperature trend and not a lot of precipitation trend. Sorry. We've seen, here's our 50s drought. We've seen more or less a wetter period in the 70s and 80s. And we've seen some really dry periods in the 2000s. However, there's been a few wet ones here during some El Nino years. And we've seen some really dry La Nina years, and I'll talk about what those are. So the 50s have been the driest. 1956, this particular year was our driest year, and this is for the county. And 1941 was our wettest. And I wish I had more time. We could talk about 1941. That was a famous year for looking at weather extremes. And it was one year we've almost filled up Elephant Butte from a dry state to almost in 1941 by the summer. So that's one of the so it's possible to see a lot of water coming down as opposed to what we're seeing now is very dry. So what causes our variability in weather? It really depends on what time scale you're looking at. So on a daily time scale, things vary, when the sun comes up and when they set. Weekly to monthly, we've got storm tracks that occur depending on time of year. Seasonal, we've got different, the sun angle as well as different climatological impacts from different parts of the earth being warmer than others. And then year to year, we've got things going on like the El Nino Southern Oscillation, which drives the El Nino La Nina. And then we've got things that are multi-decades or decadal to multi-decadal, as well as long-term. So it all really depends on your what time scale you're looking at. So this is sort of a open question. And so there's been a lot of study on this. And if you look at this was a study done by one of the first state climatologists when it was a university position. There were a bunch of state climatologists when it was a federal, but Ken Kunkel was the state climatologist here, and he has roots here in Las Cruces. And he's actually faculty over in North Carolina right now, so he's still in the climate business. But he put together a primary author in the study to say, well, what causes our stream events and precipitation and weather events here, and more than often it's these cold fronts that come in. Like more than half of them are from frontal activities, and then almost a quarter. 22% are from his extratropical cyclones. Those are storms, the low pressure systems. And then the monsoon is about 21% of our extreme values. And so those are what drive a lot of our things that impact us as a society. And so right now we're being impacted by the La Nina signal here. So this is over on the right side. So the jet stream moves further north. So most of the storms go above us in latitude. So we miss out. So we're drier than average, and they mainly impact the cool season. So it sets up in the summer, but the storm tracks miss us in the wintertime. So you usually have a warmer than average winter and a drier. That doesn't always happen that way, but it's more than average. It does that. And then when we have El Niños, the storm tracks go further south over us, and we get wet winters and cool winters. So this is kind of an oscillation. And then this is kind of what drives some of our extreme weather as well as our droughts as well. So then we have to kind of look at the whole hemisphere in order to figure out what goes on that drives our weather patterns. And so we've seen lots of extremes. If you've been here more than a decade, you've experienced a few living here in Las Cruces, and this was one that everybody who lived here in 2011 remembers this one. And this is our lows on February 3rd, 2011. So these are low temperatures in degrees Fahrenheit. So we were 5 below zero here in Las Cruces, and over in the Jornada, it was 20 below zero, a little higher elevation. And then as you go further into the Tularosa Basin, it was in the minus teens. And in a few areas outside, over on the other side of the Sacramentos, in the minus 20s. And so a very extraordinary event. And, we've seen another one that came in this past year, but it didn't really affect us here. It did make it cooler than average and cold. Bitterly cold, but not as cold as that one. But it was back in February 14th and 15th. And I just showed you, this is a temperature anomaly of the first 16 days in February. It was really cold over in the plain states, more than 16 degrees below average. And I just picked one of the weather stations that we look at. This is in Clayton, and very far in Union County. The average, these are each blue bar is the daily temperature starting in February 1st. And you can see the brown area is the average, the highs and lows. And then the red lines are the extreme highs, and then the blue lines are the extreme lows. So we've set a couple records on this particular event. You can see that a few of the times the whole day was near below zero the whole day in Clayton. So we do get these, not very often, and it depends on how far west they go. And most of this went into the plain states, and then a little bit into the Midwest and the western part of that. And then we also get, on the other hand, we get extreme heat. And our last really hot, our most hot day, remember I showed you earlier, was 1994. But if you can look on, here's a single day on the left side. The hottest day was 110. And you can see the 2017 was our second hottest. So we had a 109. And then last year was equally hot and was up to the seventh hottest day in our period of record since 1892. We had a 107 on the 10th, 12th, 13th, and 14th. So this is just the top 10 hottest 1 days. And then what's very interesting too is to look at the hot week. So the maximum 5-day mean max temperatures. So as you can see, 94 was our really hot week. We had a 5-day average temperature on June 30th, 1994 of 108.6. So that was over 5 days. So you can imagine, and then even we went into July as well. And then we also had the 5th ranked hottest was last year. Our 5-day average on the ending on July 14th was 106.8. So I don't know how you like hot, but there's not that much difference in temperature from my point of view, from 107 to 109. So it's hot as hot. And so we've experienced these, and this is a query of all the days between 1892 to the present. And you can see most of them are basically the top 9 have occurred in the 1990s and in the 2000s. So we're seeing lots of more extremes more recently. So what are the things, extreme weather? We've seen like 1941 flooding, flash flooding, and it's always looked at how it's impacts society. Transportation shutdowns, roads blocked, washed out, and how it's impacted our supply lines for food, loss of power and water. We've seen that when we had cold temperatures. And so it impacts how we respond, with medical emergencies, and then a more long-term with agriculture. And just like kind of a picture on the right here, just a example of our arroyos fill up and within minutes go from completely dry to, where you don't want to cross this because you don't know how deep it is. And some of these events have come from tropical remnants, have been really interesting. Like this 1941, we've seen tropical storms. And then actually this map here on the right was impacts of a tropical remnant in 1911. And it was actually very interestingly in San Juan County, it was the flood of record for the Animas River in Farmington. They had estimated about 30,000 cubic feet per second. And that's a lot of water coming down the Animas. Animas is not a very big river, and likely was much over the banks into Farmington, probably flooded out most of Farmington. It'd be very interesting to look at some of the archive photos from October 1911, specifically in September, the first few days in September 1911. So that would be a really cool thing to look at to see how the impacts of that. I think this is pre Navajo Dam. So, and you have to consider, the changes now with this. So some of the other impacts that we get in the satellite air, we get a view from space looking down, and we get things like atmospheric rivers. If you ever lived in California or on the coasts, we get these. I would say often, every few years or even several times a year, we get the atmospheric rivers are basically narrow channels of atmospheric moisture in the column in the bottom level of the atmosphere, and the top several kilometers, very intense but very narrow. And as the moisture comes off of the ocean and intercepts the land, you got a lot of coastal ranges. So as the air is pushed up the coastal ranges, it cools, and as it cools, it condenses and creates lots of really impactful rain. We don't get a lot of that kind of thing inland in New Mexico. However, they do get every once in a while. They do get a few of them that go further south into Southern California and dip into Arizona, and we may get a little bit of remnants of that into western New Mexico, southwestern New Mexico, it's mostly ringed out by the Chiricahuas into the western part of the Gila, but we do get some more in average, some precipitation from some of these atmospheric rivers that are more south into Baja. So most of these go into California, Oregon, but we do get, and it's fascinating to look at these on the satellite. And this is just an example. One is pretty recent, 2014. We got remnants of a tropical storm, and this is kind of how it works. We got a low to the west and a high to the east, and it's kind of bringing in moisture, drawing in moisture from the Pacific. And the tropical storm still is off the coast, but basically it draws in the moisture, and then as it goes upland into the higher elevations, it starts to wring it out. It starts to bring out a lot of the moisture, and in this particular one, mainly getting into southern Arizona, but on the western side of New Mexico, we get. And so I mentioned that one of the records we've seen in Las Cruces was actually the wettest day in Las Cruces was actually in 1935, and this was actually a paper from Leopold, and Papers Hydrology is called. In 1942 was published, and kind of gives you it's very brief, but it talks about what happened in the 2 days, 29th and 30th, the night of 29th and the 30th of August, 1935. They had 5.85 by early morning on the 29th, and then a few more. And so they were talking about water reaching a depth of 4 feet over most of the part of Las Cruces, and 100 houses were destroyed. So then they actually have a map of the precipitation, kind of estimation from to look at the gauge that we have on the NMSU, which was called New Mexico Agricultural College. That was we had 6.49 inches at measurements, but based off of other measurements of, say, like buckets and things that were collecting water, they estimated there may have been up to 8 inches falling. These are unofficial, of course, but it was estimated. So it was a hot spot over just the Las Cruces. Not a lot else going on. This is the day all over southern New Mexico. Here's our 6.49, but as you can see, not a lot in other places. So it's mainly just a intense storm in August over Las Cruces, and that was our period of record, the most rain we've had. And interesting enough, I mean, 1941 was the second, and then more recently, July of 2010, our third wettest day, and I was just started working here in Las Cruces, and it was kind of a nice welcome to see an extreme event. For a climatologist in your backyard. We had 3.34 inches, and it doesn't match that 6.49, but that's an amazing amount of water falling in one day. And I talk to people back east, and like they regularly get 3 inches of rain, but for Las Cruces, that's a lot of water. And so this is one of the maps that we generated from our citizen science network. Hint, hint, citizen science. More to talk about how to get involved in this later. But this is the map from 2010 of our citizen scientists across Las Cruces. All those dots were volunteers. And so we had 3.34 on campus. We had a 3.56 over on the far southwest on the mesa, on the very far side of Las Cruces. And we only had 1.82 at the airport. So if we relied on the airport, it wouldn't have been an extraordinary event at all. But since we've had all these other measurements, even up here in the north, we've got 2.3 inches, and all those other measurements, 2.5, 2.8, 3.3 inches. Without these citizen science, we wouldn't have known that this was an extraordinary event. Although we did have the 3.34 on campus, but it was it was very localized, but it covered a lot of the Las Cruces with more than an inch. And so this is a radar. The background colors are the radar we have at Santa Teresa, and then the dots are our citizen scientists. And it actually mapped it pretty well in terms of the comparison of the radar versus the actual measurements of rain gauges at people's houses. And so, which I was very pleased with that. And so I had a time-lapse camera in my office, and this was a picture of the storm right before at 7 p.m. So we were looking at this as it on the radar, and it was amazing. And then the morning after, I came to look at our weather station, and it had gone down a bit, but and early in the morning, 6, 7 in the morning, there was water flowing and trash cans floating down University Avenue, and our water line had gone down, not almost a foot down, but it was still inundated a lot in all across the campus. And this is a picture of the west side of campus where our weather station is, and our poor little evaporation gauge was floating around out there. And luckily we actually had a lot of rain gauges. We had a rain gauge study going on here. We had probably a half dozen rain gauges going on, and this is what it looked like on the west side of campus. So it still hadn't gone down even a day later. So this is after 3 inches of rain. So that's kind of what I really enjoy looking at is doing a diagnosis of how storms form and things like hail. And so this particular storm, I look at the radar, looking at how the hail forms and what kind of, this is actually here on campus, hail a little smaller than penny. So there's a penny here. But we can get these usually once a year, and sometimes several times a year we get these. And so how often do they occur? So this is from the COCORAS network. This is citizen science data across New Mexico, as well as the other networks. So most of the time, hail forms in May and June are most, but we can get them all throughout the fall, and even in the early spring in February, March, and April. But May and June are our most frequent months throughout the whole New Mexico. Most common size are rice to pea, but we've seen hail in New Mexico, not in Las Cruces, but as large as 4.5 inches. And we've had one of our stations, and I run a statewide network, and one of our stations in Clovis was we actually had a hailstorm there, probably a little bigger than golf balls, and it destroyed our weather station. It actually bent all the metal aluminum sensors, and we had to replace the entire station. So we've seen these, and we've been within a mile of tornadoes in some of our weather stations. We never had one destroyed. I know our folks and my colleagues in Oklahoma have had several of their stations destroyed from tornadoes, direct hit, totally mangled up the aluminum towers and everything, but not in New Mexico yet. I hope that never happens, but you never know. So this is kind of the impacts from hail. This was a photo I got from my colleague, Dr. Sonogo, back in 2015. This is a cotton field. It should be nice and green, totally defoliated from just a few minutes of hail. Other side of the coin, we've got drought, and so this is we have this product called the U.S. Drought Monitor, and we've been doing it since 2000. So we've got more than 21 years of data now, and we ranked the impacts of drought. So how strong is the drought and we have a scale from 1 to 4. 4 is the worst drought, 1 is the least, and then we have sort of this yellow pre-drought, and you can see the ebb and flow over time. And so the darkest red is the D4, the most intense drought. So we've seen it pop up once, twice, 3 times, 4 times in Doña Ana County, and we've got almost 20% of the county in this worst category of drought right now. And so where are we heading? So this map just came out yesterday. It's the seasonal drought outlook. So basically we're all this chocolate color brown. It's basically drought is going to persist at least through the monsoon. And then the lighter yellowish, and it's basically areas where it's not drought and is likely going to develop in the drought. So it's like most of the Western U.S. all the way to the Pacific Northwest is going to be impacted by drought throughout the summer. And so, and a lot of this is we use citizen science programs to help out map the extent of the drought. So let me, I've talked a little bit, I kind of wet your tongue in terms of what we have in terms of climate. So I want to kind of transition to the last third of the presentation to talk about how citizen scientists get involved. And the first program we did this this past year in 2020, we had a urban heat island mapping campaign, and we partnered with NOAA. These are all the programs that we partnered with, and we did it with the city of El Paso and the city of Las Cruces, and we mapped out where in Las Cruces is it the hottest, and we employed citizen scientists to do it, and then we all the other places here that are little circles, those were the cities who did it last summer. And actually ours was the hottest out of all of those. And it was just amazing. And so we did it on July 10th. We forecasted with the National Weather Service, picked the hottest day that we could find that didn't have a lot of clouds. And we recruited some citizen scientists. We got 11 folks from Las Cruces. And we had sensors on cars at 5 different car routes and 2 bicycle routes. And then we did 3 times a day, 6 to 7 a.m., 3 to 4 in the afternoon, and 7 to 8 at night. And we collected temperature and humidity measurements every second. So with all those 11 people, 5 car routes, 2 bicycle routes, we collected 38,000 measurements. And our maximum heat index on that day was 112 degrees Fahrenheit. So it was a great day to do it. Terrible out there for people who, if you're out there and without air conditioning, it was extremely hot. And so this is kind of our mapping that we did. So these are 2 of our volunteer observers on the car and then a bike. And these all the the blue lines are all the places where they drove. Well, with the bike on campus over on the east side of town was a bike, and then the rest of them were all car routes where we took measurements. So what do we find? So I just show you a couple maps. Afternoon, 3 to 4 p.m. This was we contoured it after bringing all the data into a computer, and we mapped it out and we colorized it, and we found the heat index in the afternoon ranged from 98 to 111 degrees in Las Cruces, and we found a significant heat across all over town. A few hotspots we found, along the Traverse Trail, and a few of the areas along kind of in the main corridors in Las Cruces. So, and we actually had the air temperature at our long-term weather station was 106. That was the high temperature of the day. However, the heat index was up to a maximum of 111. So that heat index, remember, it takes into account the humidity. So it had a little bit of humidity in the air, not a whole lot, but it actually made it feel like 111, even though the air temperature was 106. But a few areas are probably much hotter than 106. We actually, because of the heat island, basically more areas that had a lot of pavement, black tops, things like that are much higher than 106. And so I also did some infrared temperature measurements with a little infrared camera that I have, and just kind of taking shots during that hot day. What were the variability in terms of, where would you get some coolness? And remember, this is not the air temperature, but the surfaces. Just mapping out the irrigated versus non-irrigated streets versus sidewalks. How much relief can you get by being in the shade? And that was kind of the things that we presented with the city of Las Cruces. And there's one last picture of just showing, this is on campus, the skiing hole in the background. And just to show the variability, the roads were very hot. So 153 degrees for the temperatures of the ground and on the pavements, but in the 90s in the shade, so it gets significant cooling relief if you're in the shade, of course. It could sort of makes sense, but giving the data and sort of giving that, I don't really know how hot the streets were, but we've got lots of data now, very detailed data of the where people walk. It's in the order of 150 plus temperatures on the middle of the day. So that's what the urban heat island. So I'm going to transition to precipitation. So we measure through this program called the Community Collaborative Rain, Hail, and Snow Network, and we measure precipitation. So what do? We measure rain, we do hail, and we do snow, not a lot of snow in Las Cruces and not a lot of hail in Las Cruces. But however, this was actually, this was actually in my yard just a few years ago. So we do get every once in a while, we'll get a dump of hail, very localized. But mainly when it does rain, we want to be out there. So these are all volunteers. It's all about local weather. And so, so this is the website, cocorahs.org. So it's COCORAHS.org. So what do we do? How do we get involved? So, before we just celebrated our 20th anniversary of Cocorahs. We started in 1998, and in 2018 we had 20 years. And so we got more than 20,000 observers across the country, and we expanded into our northern neighbor, Canada, and into the islands in the Atlantic, the Virgin Islands, Puerto Rico, and also Bahamas. And so there's our gauge that we use. So what do we do on a daily basis? Here, basically, we use one gauge type so that we can compare apples and apples. We only accept one gauge type, and so that everybody gets the same instrument. It's a 4-inch gauge. It's about $30 with 40 some dollars with shipping. Very small and very simple, and it's easy to read. And we as in Cocorahs, we provide the information technology to enter in the data. So all the observer needs to do is go out in their front or backyard and read the data, and either log on to their computer or download an app on your phone, either iOS or an Android, and you can get your number, and then we tally it all for you and provide all the graphics and database support. And so we just need observers to take the data. And so it's very easy to do. And so we've got more than 1,000 people across New Mexico. This is the totals over last year, 2020. And all the little gray dots on the map are individual observers. Like there are people just like you and me taking data as a citizen scientist. And we got 124 in Doña Ana County. We'd love to get more. We lose observers every year, so we need to recruit more every year in order to keep our numbers high. We've got our most in Bernalillo County. We've got 175. However, we're climbing up there with 124 in Doña Ana County. We love to get folks. If you know people in other parts of the state, let them know. We pretty much have somebody in every county. We need people in Northeast, Southeast, Southwest, and Northwest, just like everybody everywhere else. And we'll take any data we can. And we do have a lot of instructions, and I lead a lot of webinars and training once we get back to face-to-face. If anybody's interested, I'd love to do a workshop training, hands-on, to get you started. This is the kind of day that I look forward to. So this was a day back in September of last year. Very moist air mass, pretty much precip everywhere. Pretty much most all of our observers had something to read, and a few of them had some snow. This was back September 9th. And the most we've had in New Mexico, we had a 1.8 inch precip, and then the average measurement of precip was 0.46 inches. And we had 65 people measure snow. It was one of the earliest dates of snow in some of the areas up here, up in Colfax and San Miguel County. However, we got a lot of good rain. We had 699 observations. And so you can see our neighboring states, all the data we get. And this is one of the mapping products that is available through Cocorahs. And so on this day, here's a picture of not Las Cruces. This is Albuquerque. And so this is kind of what we get. We've got a lot of observers in Albuquerque, but we need more through Las Cruces. And so why do we use this? What do we use it for? Well, this was one of the events back in 2016 over at Radium Springs, over at Leesburg Dam. One of the fellows who works there, we got him set up with Cocorahs, and I got a picture of him. The day after this event, we had a 4-incher in Radium Springs, and I was there. I had to go there and check it out, so I drove up to Radium Springs the day after just to get some accounts, like what did it look like, and after that 4-incher, because I mean I've seen what a 3.3 inch did in Las Cruces and what did it do here. And he actually drove me around all over the place. And it was a lot of water laying around and a few things washed out. We had another observer just northwest of Radium Springs had 3.83, but it's very localized. Just south there, we got 1.9 and over an inch in Las Cruces, but nothing near this 4-incher that we've had here. So it basically gives us some indication of how localized and how important individual measurements are. So as a member of COCORAS, you get this is actually my data from my rain gauge at home, and we generate this for everybody. So if you join, we will give you the tools to graph your data. And so this is the bars are the actual measurements, and then we have a tool that gives you the average. So based off of the computer averages, what would you normally expect? So as you can see, our lows are usually in March and April. However, I got some really good dumps of rain in March, and even more than we actually had in July. And this was back from the water year summary from October 19th through September 20th. And so we had I measured 10.71. There was a few months we had nothing. So it's really interesting how we can get very close to the average, but on a particular month is very different. So this is one of the treasures of data to understand, what goes on over time. And so we report because we use it for drought as well. So I do a lot of social media marketing with COCORAS, providing these things to several thousand people. And I encourage folks to report the zeros because that's data. And so there's a picture of one of those times on this right, all those gray dots are zeros. And we really treasure because we need to know when it didn't rain as opposed to how much did rain. And a few other things with COCORAS, there's a lot of training. We do things called evapotranspiration, so we can really geek out, as well as helping understand conditions of drought. This is called condition monitoring. So that's another facet of being a COCORAS observer is helping out with drought monitoring. And so this is one of the fruits of that labor is the background is the U.S. Drought Monitor, and all the triangles are individual COCORAS observers reporting what's going on in their backyard. And so I generate these maps on a weekly basis to see what's going on. And basically it's people telling us what it looked like, how bad is it? Okay, so I'm going to transition to a couple more, very, very brief, couple more tools for citizen science. And this is more of a storm chaser. It came out of the storm chasing community. It's called MPING, and it's an abbreviation for meteorological phenomena identification near the ground. And so MPING is an app. As you can download this app and you could report what's going on where you are. And basically it's crowdsourcing of weather. And so weather storm chasers use this all the time, and it basically uses their phone GPS, and you can report all the different types of precipitation: rain, snow, hail, wind. If you've seen tornadoes, if you see flood, mudslides, even dust storms, reduced visibility, fog. And so it basically, and then it goes into a long-term archive at the University of Oklahoma. So that's where, kind of the home area of a lot of storm chasers. And just as an example, this is the storm from February of this year. So this is, I just picked a one snapshot, some February 14th in the evening, 2021. These are all the little snowflakes or reports of snow, and it was rain in near the Houston area, and all the reports of snow all across the, the Mississippi Valley, Ohio Valley, even, and rain in the Carolinas all the way down to Atlanta and Georgia. So this is what the data is used for. And so you can download this and make animations of, so the data is used not only by storm chasers, but the National Weather Service uses these and it goes into warning, severe weather and emergency management. So it's a nice tool that's used. The last tool I'm going to show it's actually a NASA funded program, and it's actually part of the GLOBE program, which is a global educational program funded some part in part by NASA, but other funders as well. So other people in other countries participate in this for all kind of environmental monitoring. But there's one part of that, it's called the cloud observation. And so, and one of the things that we have here in southern New Mexico is dust storms. And so they actually, we requested the cloud, we include dust as part of one of the observations. And there's a picture of the advertisement on including, if you see dust. So if this is actually a picture of one in Phoenix, if you see a haboob, or a big wall of dust coming in, you can report it with the cloud observation app. And this is sort of a screenshot of the app. And you can actually check for satellite flyovers and log your reports in there. So this is a third way that you could become a citizen science observer for climate. And all this data gets archived in use and for future use and studies and to look at over time. So first one was COCORAS, then MPING, and then Globe Observer. So you got 3 different opportunities if you're interested in taking climatological environmental measurements. There's ample opportunities. You just all you need to get is an account, or the last 2 things here, you get a smartphone and download the app and then have fun and just start collecting data. So I'm going to stop there. I'm sure I've given so much information for you guys, but if you have more questions, email me, or if you're on social media, I'm on Twitter, quite active on NM Climate. I report on any environmental, air quality, climate, weather things across mostly New Mexico. And so if that's not your thing, email me if you want to get in touch, or if you're interested in COCORAS, go to cocoras.org and have fun. There's online training that you can do. And then if you're interested, let me know, and we can always get a group together and have a virtual training, or if you want to wait until later, we can do a face-to-face, outside with masks on or something, whatever works out. And so I'm glad to help out. I do that as one of my things I do. I'm the state coordinator for COCORAS, so I help out all over the state, and working a lot in tribal areas in the northern New Mexico, and trying to get folks connected and get more data, and helping out with the climate monitoring. So I'll stop there, and we can I'll entertain any kind of question.
Thank you so much, Dr. Dubois. That was fantastic. Really enjoyed learning about our historical climate information, as well as what's going on today. If anyone has a question, feel free to unmute and ask your question, or if you prefer, you could send it through the chat and we would be happy to read it.
David, can you comment on the thickness, the depth of the cold air that's out there in the plains when it comes down and seems to be blocked by the mountains? I grew up in Nebraska. My dad worked on an office building, and he talked about being into the 8th floor and the temperature being in the upper 30s and coming down on the street, and it was snowing. So it seems to me the implication is that that cold air is only a few hundred feet thick.
Yep. Yeah. It can be really, really shallow. There are we don't have a lot of measurements in measuring the temperature as a function of height. However, we do have some models that provide that, and so there are some measurements that it's within the bottom several hundred feet, and then even further down on the ground, depending on what kind of surfaces. Is there snow already on the ground, or is it wet? Depending on that, you can get gradients of very, very cold, and then you can get and there's a thing called a low level jet. Basically, it's a channel of high winds that can redistribute and create different environments, as well as things that these really intense cold fronts that come in. We call them backdoor cold fronts here in New Mexico. They come in from the plains off of the areas, and their origin are in Canada. And as they get a lot of their energy comes, and sometimes they'll reach New Mexico and creep up the mountains. And we've seen those, this year with that. And yeah, it's really shallow. I mean, it really depends on the stability of the other air mass that it's coming in contact with. And so they'll ride the warm air rides above it and creates a temperature inversion, and the cold air really kind of digs in. So yeah, and it's a fascinating study to look at the temperature distribution and amount of energy required, especially when it forms clouds and fog and things like that. So it's fascinating.
Other questions?
And some of the implications of those are my colleagues in the Midwest and the Plain States. They're in agricultural applications. They do spraying, of like herbicides, and they're really interested in that lower level, even the bottom, 20, 30 feet, even the bottom like 10 feet makes a difference on how the pesticides, they call it spray migration. If they spray here, how far does it go? And they've seen sort of like herbicides, they can go like up to a mile past where they're needed, and things. So there's a lot of implications for that, and so there's serious business when you're dealing with spray drift. Not so much. Some of it's in New Mexico, but it's more in the Southern Great Plains, Plain States. So yeah.
Any other questions? All right, we got a text message here, David. Let me pull it up. Judy Messel asks, could you talk a little more about the mega drought of the 16th century? Is there evidence of how it affected people living in New Mexico at the time?
Yeah. So here we've got example 15s, late 1500s, and then we've got, here's another example, early late 1600s. So yeah, I mean, it's I think, I started reading some of those, and I know it's been fascinating. I have a weather station up by El Morro National Monument, and after I service the weather stations, like sometimes I'll go for a little hike after lunch, and in the lava tubes, and it was fascinating. I read a paper recently that if you go in the lava tubes, some of them are pretty big, and they actually have the water inside remains frozen over time. There's actually one of the places you can visit. If you pay, you could see one of those, and it has frozen water even in the summer. And actually some of the Puebloan folks use that to store water in times of drought. And they've seen evidence of people painting on the walls, so they know people stored water and they were there over time. So there was a lot of adaptation that goes on that we're learning about for these mega droughts. And of course, they, what I've read and what I've talked to folks, that a lot of them, there's migration that occurred as a result of that. They picked up and moved their village. They weren't as, that was their adaptation. They were had to find food from other places, or otherwise they become extinct if you don't have your animals to draw from, or the vegetation to eat, or the water to supply that. And I imagine it'd be interesting to see how much water was available. I haven't really read a lot about that yet in terms of stream flow. I know there's been some studies on that on the Colorado But, I think there's still a lot more to learn about the societies back then and how they adapted or didn't adapt during these major stressors. There's many years. It's not just 1 year, but decade, more than a decade, 24 year.
Thank you for that question, Judy. Anyone else have a question for David? All right. I guess we will wrap it up then. David, thank you so much for doing this presentation. Really enjoyed it. We will look forward to seeing everybody back here next month, the third Thursday of May, for Dr. Timothy Nelson, again talking about the Blackdom settlement out in the plains there by Roswell and the Afro frontier. Thank you for coming, and we will see you next month, hopefully. Thanks again, David.
You're welcome. Glad to be here.